Hi, welcome to the calculating change in enthalpy video. We're going to go over in this video, which I may divide into two parts, example problem, problem 1 from the packet and also problem 9. So before we get started, remember enthalpy or change in enthalpy of a reaction is used to measure the amount of heat lost or gained during a reaction due to the breaking and the formation of bonds. So bonds have different types of energies stored within the bond, and we can use these values to calculate the change in enthalpy of a reaction. So to calculate the change in enthalpy of the reaction, what we need to do is we need to know the total energy stored in the bonds of the reactants and the total energy stored in the bonds of the products. So let's start with getting the enthalpy in the reactants. The first bond that I noticed on the reactant side is the carbon-oxygen triple bond, called a triple bond because there are 3 bonds connecting these atoms together, these 2 atoms. That bond, carbon-oxygen triple bond, according to this table here, has an energy of 1072. There's also a hydrogen-hydrogen single bond on the reactant side, and that has a bond energy of 432. And again, I'm just getting this information from the chart. So find the bond in the chart and that corresponding energy. All right, so what's the overall energy here on the reactant side? So it's going to equal the 1072 from the carbon-oxygen triple bond. And since there are 2 hydrogen single bonds, since there are 2 hydrogen or H2 molecules, there'll be 2 hydrogen single bonds on the reactant side. Looking at that coefficient there, I'm going to take the energy of that bond and multiply it by 2. So again, this 2 comes from the coefficient. All right, when I add that together, I get the total enthalpy on the reactant side to be 1,936 kilojoules. Okay, now we're going to do the same thing on the product side. There's only one product here, but this product has multiple bonds. So we need to go through and make sure we get all of the bonds. All right, so the first bond I notice is a carbon-hydrogen, or you call it hydrogen-carbon single bond. And those types of bonds have 413 kilojoules of energy. And you'll notice that in that molecule, I have 3 of those bonds. 1, 2, 3. I'm going to do 3 times 413 for my carbon-hydrogen single bond. The next bond I see is a carbon-oxygen single bond. That has 358. And there's only one of those. And an oxygen-hydrogen single bond, which is here, and that has 467 kilojoules. So again, I add these together, 3 times 413 plus 358 plus 467, and that gives me a value of 2,064 kilojoules. Okay, so now what I need to do is I need to calculate the change in enthalpy of the reaction, again using this equation. So according to this equation, I'm going to subtract the sum from the products from the reactants. So 1936 minus 2064, sorry. And Rxn, by the way, stands for reaction. So the change in enthalpy for the reaction is equal to 1936 minus 2064. And when you calculate that, you get negative 128 kilojoules. Okay, last thing is to determine this is endothermic or exothermic. Since the change in enthalpy for the reaction is negative, we know this is exothermic because the change in enthalpy is less than 0 or negative value. All right, so just to recap, to calculate the change in enthalpy of the reaction, you calculate the sum of enthalpy on the reactants and the product side by adding up the energy stored within the bonds. We need to be careful and use coefficients to multiply the bond energy by the coefficients when appropriate, or if a molecule has more than one type of bond, to multiply that out as well, as we saw that we did here. All right, then after we get our two values for the reactants and the products, you subtract them, and the sign tells you if it's exo or endothermic. Exo would have a negative delta H, endo would have a positive. Okay, so that's it for practice problem 1. The next video we'll go over practice problem 9.